Hello guys, now I'm going to explain about how to operate CoCalc project using SageMath. Okay, so let us start. Just type SageMath on your browser. Just click on SageMath and select Sage on CoCalc. Now here it will ask sign in. Just get into sign in, and you have to if you have a Gmail account, just press a Gmail account, and I'm going to select my Gmail account. And this is the dashboard of the CoCalc. Okay, now just select your CoCalc projects. Just select it. It will open CoCalc projects. You can create as many number of projects you want. Suppose if I want to create a new project, just create a new project. Here I am typing the name as sample and create a project. Yes, here I have created my project, and here if you want you can add any number of files which you want to work out on Python. If you want, you can work out SageMath, you can work out, and many languages also you can work out. So here I am going to create a new one, and here I want to select SageMath worksheet. Since we are working on the SageMath, so I am going to create SageMath worksheet. So it is going to create one SageMath worksheet. Okay, so this is how you can get into the SageMath. So now let us start with our first worksheet. I am going to start first worksheet. So let us start with the topic exploring integers with SageMath. Every time after entering the symbols or commands, just press run on it. Otherwise you can press shift enter. For running the command you have to enter shift into enter. Okay, so let us start with a number, assigning one number. If you want to assign any number, you can just type n is equal to some number. Here I have entered n is equal to 67, and if I want to find a type of that number, just write type of n. Okay, so let us see the output of this. So it will create integer. Since 67 is an integer, it is showing class is 67. Suppose if I want to change it into some point, 0.8, let us see the output of this. So it is saying real number. Since it is taking the class, since because this is a digit number, so we call it as a real number. Suppose if I am writing a square root for it, so let us write the square root sqrt. Square root symbol is sqrt. Square root of suppose if I take that n only, where n is a 67, so just I am going to assign this to some other variable, that is q, not q. I can take it some other letter as some d is equal to this one. Okay, here I got, since we have entered type of n, so it is showing that. Now if I want to type d, so let us see c, type of d I am going to select now. Let us see the output. So expression, so d is equal to square root of n, it is showing it as now expression, so that you can identify the type of number which you have entered. Okay, so this is about assigning the number. Now let us see one more. If I want to find the factors for 67, so you can write n dot factors. Okay, just execute it. We'll see the output. N dot factors for 67. Since 67 is a prime number, we are getting no factors. Suppose if I change it to some numbers which are having factors, so I'm going to evaluate it. Just shift enter, you'll get 2 into 3 into 11. So 66 is a product of 2 into 3 into 11. Okay, next I am going to check whether n is a prime number or not. Okay, so just run it. So it is showing false because 66 is not a prime number. Suppose if I entered this number as 67 and execute it, and now if you run it, it is showing true. Okay, since 67 is a prime number. Clear? Next, work out on another command. I want to know what is the next prime number for 67. So if I select that, it is showing 71 is the next prime number to the 61. Now if I want to find the previous prime number for 67, just run it. It is showing 61 is the nearest prime number before 67. Okay, next, if I want to find the divisors of n, so let us see the divisors of n. Since 67 is a prime number, it is showing 1 comma 67. Suppose if I change this 67 into 65, just run it, and divisors for 65 is nothing but 1 comma 5 comma 13 and 65. So total 5 divisors we got. Now if I want to find the number of digits in n, so let us see the number of digits in n. Okay, 5 comma 6. We have entered 65. It is showing 5 comma 6. So in the sense means here 5 represents tens digit. Okay, sorry, 5 represents units digit and 6 represents tens digit. Okay, so it will take in that sense. So suppose if I want to change this as 651. Okay, let us see the output of n dot digits. So here I have to execute it. So now it is showing 1 comma 5 comma 6. Since I have entered 651, in units digit 1 is there, tens digit 5 is there, and hundreds digit 6 is there. So in that manner. Okay, now if I want to find the length of the digits, okay, so let us see the length of the digits. Length of digit means how many numbers are there in our entered value. So here I have 651. In 651 we have 3 digits. Okay, so it is showing length of the digit is 3. Now I am going to change the number. M is equal to 2 3 4 5 6, and I want to find m dot n digits. Let us see what is the output. So m dot n digit, this is one more way of representing length of digits. Okay, instead of entering length of n dot digits, here directly you can enter m dot n digits. So if you enter this command, it will show number of digits in the given value. Okay, next see m dot digits. So in m dot digits, let us see what is it showing. 2 3 4 5 6, that means in units digit 6 is there, tens digit 5 is there, hundreds digit 4 is there, thousands digit 3 is there, and 10,000 digits 2 is there. Okay. Next, n dot n digits. So let us see. That means n means we have assigned 651. So for that number it is showing 3. Okay. Next, suppose I want to find the divisors of this expression. Okay. 2 plus 3 into 3 power 2 into 17. I want to find the divisors of this whole number. Okay. So just execute it. It is showing divisors of that particular number. So we don't know what is the total value of this. So it is only by default it is calculating, and it is calculating the divisors also for that expression. Let us see. I am going to assign a value and b value as 7, 6, 4, 2 and 63. So we can do this in many ways. You can assign two values at a time. Suppose I want to change 7 and this as some 3. So you can change the values, and even you can assign more than two values also in the same way. So I am going to assign a comma b in a single line. So a value I have taken 7 and b value I have taken 3. So I am going to run this. Now I want to print these values. So we can use the print command in the SageMath. So just press print of a comma b. It will print 7 comma 3, since I have entered 7 comma 3. Now I am going to find a by b. So you can directly press 7 by 3. It is showing 7 by 3. Now I want to find, since I have assigned values and I have put a by b, now directly you can enter this value also. So 38 by 12, it will show 19 by 6. It is going to factorize, simplify this and show the expression. Now if I press 13 by 12.0, it will show the value in terms of real number, that is in terms of digits. So the total value is 13.1666 something. Clear? There is one more way of representing the real number as 38 by 12 point numeric n of bracket, closed brackets. Clear? So if I press this one, this command, it will show 3.1667 something. So it will give the value in terms of real numbers. Next, a percentage b. A percentage b gives 1, because 7 by 3. 7 by 3 represents how much? 2 point something. So remainder is 1. So it is showing the remainder. A percentage b gives the remainder of a by b. Clear? Next, b dot divides a. So if I want to check the expression whether b is dividing a or not, so it is giving false. Suppose if I change the value as, instead of 7, if I give 6, and I am going to run this, I am going to print this and a by b value. Now let us see whether b divides a. Yes, you can. B means here 3 and a means 6. So b divides a here. Now I want to check this condition. What is this condition called? Euclidean algorithm. So b into q plus remainder is equal to a. Okay. So it is not showing. So I want to change the numbers. Let us see. I am going to change this as 7 only. Just run it. I am going to run this. I am going to run this Now let us check about this condition. So it is showing false. Let us run this. So b into quotient plus remainder, it is showing false. So Euclidean, it is not showing Euclidean algorithm. That means it is A is not dividing B. Next, I want to find the GCD of A comma B. GCD of A comma B is 1. Highest common divisor for A comma 1 is this one. Next, if I want to find, there is one more way of calculating GCD, that is A dot GCD. So it is also showing 1. So two ways of representing GCD of two numbers, that is GCD of A comma B and A dot GCD of B. Now if you want to find X GCD of A comma B, so I think you know what is X GCD, extended GCD of two numbers. So will you represent extended GCD of two numbers? GCD can be expressed as some expression, that is B is equal to ST plus BT. That means GCD value can be expressed, suppose your GCD is 1. 1 can be expressed as 7 into 1 plus 3 into minus 2. Gives the number as 1. Greatest common divisor. So greatest common divisor can be expressed as in terms of given two values. So in that way you can find the XGCD. Next, D comma X comma Y is equal to XGCD of this one. So I am going to run this. No output is coming. Now if I want to print these values, just you can print like this. So D comma X comma Y is equal to XGCD, where D gives the GCD value and X and give the numbers in such a way that 7 and 3 gives the GCD. Clear? Now I am going to check this expression whether it is satisfying or not. These are extended Euclidean algorithm value. So it is satisfying this, so it is showing true. Now I want to give n is equal to 500. I have assigned n equal to 500. Now I want to check prime number of 5 value of 500. 5 value is nothing but Euclidean number. Euclidean number of 500, that is 95 will get. Now you clear 5 of 30, that is 8. Now if I want to find GCD of some number ranging from 0 to 31, so that means we can use the for loop for it, so that it will take k equal to 1, 2, 3 in such a way that GCD of some number up to 31 gives the result as 1. So these are all the numbers with 30 which gives the GCD as 1. Okay. Next, I want to find the length of the numbers which are going to give GCD of that number comma 30 is equal to 1. So we can use the length command, so it will give the length. So total 8 numbers are there, that is 1, 7, 11, 13, 17, 19, 23 and 29. Now as I said, we can assign more than 2 values also. So here I am going to assign 3 values at a time. Just run this. So now I want to find the GCD of these 3 numbers. So GCD of these 3 numbers can also be calculated as GCD of first 2 numbers comma third number. So which gives the result as 2. Next, P is equal to 147. So I have assigned the value as P is equal to 147. Just run this. Now I want to find the factorial of 147. So it will give the factorial of 147. So just I am going to press the run symbol every time. Okay. Now we can assign factorial in many ways. First method is p dot factorial. Second method is n is equal to factorial of n. I have assigned this. Suppose if I want to find n dot n digits, it will show 1000. So I am going to assign this value as some p, some q. Now I am going to find q dot n digits. So just I am going to run this. Just run this. So we have total 257 digits in that factorial. Next, I want to find the number of digits here. So here I have entered, instead of n, I have to enter q here. Just I want to find number of zeros in that factorial. So just enter that. Total 57 zeros are there in this factorial. Next, now I want to find sine, trigonometric value. So it will show sine of 3. Now I want to find the value of sine of 3. So you can just simply enter sine of 3 dot 0. So it is showing in terms of real numbers. Another way of writing this is square root of 7. If I want to find the square root of 7, it will show the expression itself. Now if I want to find the value, show square root of 7, it will show it in terms of symbols. Now if I press square root of 7.0, it will show the value of square root of 7. So in this way we can calculate the value of square root of 7. Now I want to find the number of digits in square root of 7. So you can write up to 50 digits, it will show square root of 7. So this is about the basics of SageMath.